Here in section 8.3, we're going to be talking about using systems of equations to solve word problems. And the good news is, systems of equations will allow you to go back to earlier word problems and redo them with better techniques. So some things that may have been challenging in the past may be a little easier now. But that also means we're going to take a look at some word problems that were probably too tough to talk about in the past. And so now the overall difficulty level is probably going to stay about the same. So first of all, let's talk about how things change now that we can do systems of equations. So here's an old sort of a problem. We're talking about the perimeter of a basketball court. Basketball court is a rectangle. Back before chapter 8, we would have had to have called one of the sides of the rectangle x, try to describe the other side of the rectangle as something related to x, like in this case 2x plus 6, and then build an equation using just x. And honestly, that technique will still work just fine. If you want to do this problem using the techniques from before chapter 8, you'll probably succeed. But here in chapter 8, we have something new that we can do that might be a little easier, might make more sense. You can skip the step in the beginning where you try to figure out which side is x and what do I call the other side. Here, just call them width and length. Just use w and l. You can use two variables now that we're in chapter 8. Where it says the perimeter is 84 meters, that's a fairly simple equation to build. Perimeter is the distance around, so that would be w plus l plus w plus l, so that overall you would have 2w plus 2l has to add up to 84. And then the second part of the question says the length is 6 meters longer than twice the width. Just use word-for-word translation there. Don't try to do it all in one go. Length, L, is means equals, 6 meters longer than, so something plus 6, twice the width, 2w. And notice that we've created a system of equations. It's two equations with two variables. And if you look at it, it's a fairly easy system of equations. I'm just going to take L and plug in to the other equation using the substitution method here. So 2w plus 2l equals 84. And we're putting in 2w plus 6 instead of l. And the next few steps are fairly straightforward. Distribute in the 2. Collect your like terms. Subtract the 12. And divide by the 6. But don't forget, that is only part of the answer. The question here is, what are the length and the width? So your answer should be, the length is, and say something, and the width is, and say something. So w equals 12, that's not an answer. It doesn't completely answer the question. You also need to figure out what L is, but we kind of have that ready to go here. L is 2 times w plus 6, so that'll come out to be 30. And one other thing I'll suggest is don't just say the length is 30, the width is 12. That's not 100% clear. 30 what? Inches? Well, that's a very small basketball court. 30 miles? That's way too big. So the 30 is not 100% clear until you use the right units of description with that number. So 30, 12, in this case they're meters. We've been talking about meters in this problem. So the answers we're getting are meters. Always put units on your numbers if you can, because it clarifies what they actually mean. Now this word problem could have been done without a system of equations, so it's illustrating the new technique, but it's honestly not all that complicated. What was really going to be the challenge for section 8.3 is problems that are like this. These problems are often very intimidating to students. As soon as they see them, they start to panic a little bit. So let's break down the different elements of what's going on here and focus your mind on just a couple of key ideas one step at a time. So the first key idea I want to focus you on is what this means here. When we say 36 ounces of a 14% solution, what does that actually mean? Well, luckily, it means a fairly simple thing. It means 14% of the 36 ounces is, in this case, is salt. And that can be translated into mathematics very easily. 14% is 0.14 of 36 ounces means times 36. The word is always translates as equals, and that equals the amount of salt that's going to be in that when you're all done. 14% of the 36 ounces has to be salt. Translates into this. And these mixture problems always have this pattern to them. So this is a general rule that you need to get used to. And it's luckily a fairly simple general rule. And that is that the percent times the quantity is the amount of whatever it is that you're talking about in your mixture. In this case, we're talking about salt. So that's one of the challenges in these problems. Make sure you know what to do with the percents. The percents are going to be multiplied by quantities, and they're going to give you amounts of salt in this case. Now, the next key idea has to do with what it means when we're talking about mixing. We've got these two quantities, how much 18% solution and 9% solution need to get mixed to make 36 ounces of a 14% solution. So there are two variables here. There's going to be some amount of the 18% solution and some amount of the 9% solution. So the variables here, you can use any two letters. I'm, of course, going to use X and Y. Those are the traditional ones in mathematics. But those two amounts are what we're trying to figure out. So X is going to be how many ounces of the, well, let's see, that's the 18% solution we're going to need when we're getting the right mixture. And Y is going to be the number of ounces of the 9% solution. So two key ideas. The two variables represent the quantities of what's getting mixed to make the result. And for percents, it's always going to be a percent times a number of ounces, percent times a quantity. Since we're using two variables, we're going to have to build a system of equations. There's going to have to be two equations. So let's talk about how we accomplish that. The way we accomplish that has to do with thinking about two different elements of what's happening here. There's sort of like the rough draft where you are being very sloppy and you don't care about the percents. And then there's sort of the refined, more accurate scientific way of looking at the problem. The sort of rough draft, sloppy way of looking at the problem is that we just need to make sure we get 36 ounces when we're done. If you mix together 10 ounces and 10 ounces, you're not going to succeed. You won't get 36 ounces. That's guaranteed to fail. It can't possibly work. So what that means is whatever you pick for X and whatever you pick for Y, at least make sure they add up to 36. 10 and 10 is not a smart choice at all. 10 and 26 probably won't work, but at least it makes some sense. So that is an equation. And it's such a simple equation that people often don't even think about it. They don't even bother to consider the fact that these two things have to add up to 36. But that's half of what we need to get started on this problem. So we're already halfway there. And then the second equation has to do with making sure you end up with the right amount of salt when you're done. When you're all done, you need to have 14% of the 36 ounces, however much that is. So you grab a calculator, you compute it out, you go 0.14 times 36, and you find out that that's 5.04. That's how many ounces of salt you need to have when you're done. Well, where's that salt coming from? Well, it's coming from the stuff we're mixing in there. It's coming from 18% of X, the stuff you're pouring in from the 18% solution. 18% of it is salt, and remember it's percent times quantity, and 9% of the Y stuff. Do you see the mistake I just made? I just realized it as soon as I was writing it. Pretty obvious mistake. Yeah, 9%. 9% is not 0.9. 9% is 0.09. Everybody makes mistakes like that. Don't feel ashamed if you make that kind of mistake. Just catch it, fix it, go on. It's real easy to make that sort of error. Okay, we now have a system of equations that we want to solve. We have the equation x plus y equals 36. We have the equation 0.18x plus 0.09y equals 5.04. And that's a pretty tough system of equations. You can solve it using substitution, or you can solve it using elimination. What I'm going to do here is I'm going to solve it using elimination. The main reason why I'm going to use elimination is because it gives me an opportunity to get rid of the decimals here. If I take this equation and I multiply everything by 100, then I don't have decimals anymore. I do end up with fairly large numbers, but at least there's no decimals. And if I'd like to set everything up to work out quite nicely for the y's to eliminate, I should take this top equation and I should multiply through by negative 9. So that'll give me negative 9x minus 9y equals, well, let's see, what's 9 times 36? Again, don't try to do these things in your head. Go ahead and use a calculator, negative 324. Add these up. 504 minus 324 is 180. And the math gets easy at that point, right? 180 divided by 9, x is 20, and keep in mind they're supposed to add up to 36. That means y has to be 16. All right, are we done? No, we're not done. That's not the end of the problem. You still have to write up a word answer. The question was, how much of these solutions do we need? We need 20, don't forget units, ounces of X, which was the 18% solution, and 16 ounces of the other stuff, the 9% solution. Word problems should always have word answers.